Hey everyone, welcome back to 3D Nut. In this tutorial, I'll show you exactly how I built this 100-piece puzzle, piece by piece, until the final render. I'm going to start this project by downloading a JIGSAW template. The link to this page is in the video description. Here I'll set the corner radius to 0mm, tiles to 10x10, and the size to 300mm. Now just click the download SVG button and we are ready to go to Blender. Let's set up the scene. Press A to select all objects in the scene, then press X to delete them. In the Scene Properties tab, open Units, then set the unit length to millimeters. Now let's import the JIGSAW SVG file. In the File menu, go to Import, then select SVG. Navigate to the folder where you downloaded the file, and double-click it to import. Notice that Blender imported the SVG files as curves. Curve, curve.001, and curve.002. From the top view, select curve.002. To make sure the curve is closed, press Tab to enter edit mode. The curve is open, so let's close it and join them into a single curve. Select these vertices, press F to make segment, then press Tab to exit edit mode. Now press A to select all curves, and Ctrl+J to join them. Let's enter the curve in the 3D viewport. With the curve selected, press F3 to open the search menu and choose Origin to Geometry. Then press N to open the sidebar and set the X location to 0, the Y location to 0, and the Z location to 0.1. Finally, let's set the curve's resolution. In the Data Properties tab, set Resolution Preview to 16. If you plan to make close-up shots of a single piece, you can increase it, but try not go beyond 32. Let's create the base mesh for the Jigsaw puzzle. Press Shift+A to add, go to Mesh, and choose Plane. Press A to select both objects while keeping the plane as the active selection, then switch to Edit mode. Here you're going to project the curve onto the plane to cut it. Go to the Mesh menu in the header, and select Knife Project. Depending on the curve's resolution, this may take a while. When it's done, enable Face Selection and select the two outer faces. Press X and choose Faces to delete them. The base mesh is complete, so let's return to Object mode. Since we don't need the template anymore, go to the outliner, right-click the SVG collection and choose Delete Hierarchy. Now we'll separate each piece, give them thickness, sharp, and round some corners. Select the plane, go to Edit mode, and press A to select all faces. Let's start by making sharp corners on these edges. Press Ctrl+Z to open the Edge menu, then select Mark Sharp. Next, let's separate each piece. Press Alt+M to split, and choose Faces by Edges. Then press P to separate, and select by Loose Parts. The base mesh is now split into 100 Jigsaw puzzle pieces. Now we need to assign the origin point of each piece. In Object mode, press F3 to open the search menu and select Origin to Geometry. To finish, let's add thickness and round some corners. With all pieces selected, go back to Edit mode and press A to select all faces. Press E to extrude, then press Enter to confirm. In the bottom left corner, expand the Adjust Last Operation panel and set the Z value to 1.8mm. Now with only the top face of each piece selected, press Ctrl+B to bevel, then press Enter to confirm. Set the bevel width to 0.8mm and segments to 4. The modeling part is finished, so let's batch rename this object. In Object mode, press Ctrl+F2 to open Batch Rename. Set type to Set Name, Method to New, and rename them starting from Jigsaw.001. Now we have 100 pieces numbered from 001 to 100. For the final touch, right-click and select Shade Auto Smooth. Now let's check the UVs by switching to the UV editing workspace. This step is going to be very simple since I have a square puzzle. In the 3D viewport, press numpad 7 to go to the top view and numpad dot to zoom in. Now press A to select all faces, U to unwrap, and choose Project from View Bounds. Now that we've handled the UVs, let's create the material in the shading workspace. Here I'll create a single material for all the pieces, Then I'll create a procedural mask to mix the shaders. For these shaders, I'm going to use two PBR textures from MSCG.com, Paper 6 for the cardboard and Plastic 17A for the paint. You'll find all the download links in the video description. As for the paint base color, I'll leave that to you since it's personal taste. Here I'll use one that I found online just to demonstrate. Let's create the material. In the 3D viewport, select any piece, press numpad/ to go to local view and rotate it a bit. Now click New to add a new material and rename it Jigsaw. Let's create a procedural mask. Press Shift+A and add a texture coordinate node. Press Shift+A and add a separate XYZ node. Now connect the generator socket to the vector socket. With the node wrangler add-on enabled, let's preview these nodes. Hold Shift+Ctrl and left-click the separate XYZ node to preview the X. We can now see a gradient going from 0 on the left to 1 on the right. Click one more time to switch to Y, which is front to back, and one more time for Z, which is bottom to top, the one we need. Since I need a sharp transition between 0 and 1, let's add a color ramp and place it over this noodle chain. To make the transition sharp, set the interpolation to constant. To place the transition at the start of the bevel, set the Y color position to 0.555. Now we have a mask for this material. Black will be the cardboard and white will be the paint. To organize, add a frame. Then select all nodes from the mask and drag them inside. Place it, then press N to open the sidebar and set the label name to mask. Now create the cardboard shader, and for it, we're going to use the Paper 6 PBR textures. Hold Shift+Ctrl, then left-click to preview the principal shader. Then press Shift+Ctrl+G to add the principal texture setup. By doing this, we can load multiple textures at once, and Blender will create all the connections for us. Here I'm going to use the Paper 6 color, roughness, displacement, and normal GL maps. After selecting all, press Enter, and Blender will set them up. Notice that Blender also added mapping, normal map, and displacement nodes. But since I'm not going to use the displacement node, let's change it to a bump node. Select the node, then press Shift+S to swap, and search for the bump node. Let's reconnect them. Connect the normal map to the bump, and set the strength to 0.25. Then connect the bump to the principal shader's normal socket. Because I use project from view in UV editing, the textures look stretched on the sides. So instead of using UV, let's use object coordinate for this one. Select all image textures, and while holding Alt, set the projection method to box. This fixes the stretching problem, but it creates another. Let's assign this material to all the pieces so you can see. In the 3D viewport, press numpad/ to exit local view. Press A to select all pieces while keeping the shaded one as active selection, then press Ctrl+L to link and choose Link Materials. If I zoom in, you'll see how the texture repeats across all pieces, making it look unrealistic. To fix this, add an object info node and place it inside the mapping frame. Now connect the random to the mapping location, and the problem is solved. Here I'll also set the mapping scale to 2 to make the texture smaller. The cardboard shader is complete, and I'll use it as the base for the paint shader. Select all image nodes, the bump, the normal map, and the principal shader. Then press Ctrl+G to create a node group. By doing this, it will be easier to duplicate and organize. Press Tab to exit the node group and arrange the nodes. When everything is in place, set the node group label to paper. Now create the paint shader, and for it, we're going to use the Plastic 17A PBR textures. Let's duplicate the node group. With the paper node group selected, press Shift+D to duplicate. Click to make a single user copy and connect the UV coordinate to the input socket. Hold Shift+Ctrl, left click to preview, then press Tab to edit the node group. With all image textures selected, hold Alt, then set the projection method to flat. Now let's replace these image textures. Click to make a single user copy and open to load the texture. Then load the base color map for the puzzle. Click to make a single user copy and open to load the texture. Then load the plastic 17A roughness map and set the color space to non-color. Click to make a single user copy and open to load the texture. Then load the plastic 17A displacement map and set the color space to non-color. Click to make a single user copy and open to load the texture. Then load the plastic 17A normal GL map and set the color space to non-color. Press Tab to exit the node group and set the node group label to paint. Now let's mix these two node groups. Hold Shift plus Ctrl, right-click one group, hold, then drag and release over the other group. This creates a mixed shader node and connects the groups to both input sockets, the paper group on the top and the paint group on the bottom. This works like the mix color node, but instead of colors, it mixes two shaders together. We can control it with the slider, going from 0 to 1, or black to white. If set to 0 or black, it outputs only the top shader. If set to 1 or white, it outputs only the bottom shader. Since black and white represent 0 and 1, instead of using the slider, let's just use the mask we created. To do this, just connect the color ramp to the factor. And if I isolate one piece, we can see it working. The paint on the top and the cardboard on the bottom. The material is complete. To finish this project, let's set up a basic render. Let's add a camera to the scene. Press Shift plus A and add a camera. In the Add Camera panel, set the Z location to 1 meter. Then press numpad 0 to go to the camera view, Z for shading, and select Render to preview the final scene. To light the scene, I'll use an HDRI. In the World Properties tab, click the yellow dot next to Color and select Environment Texture. Then click Open and load the HDRI. I'm using the Photo Studio Loft Hall from polyhaven.com. Next, go to the Render Properties tab and enable Ray Tracing. Under Film, set it to Transparent Background. And under Color Management, set it to Chronos. To render a 4K resolution, go to the Output Properties tab and set the resolution scale to 200%. Now press F12 to render, and this is the final scene. If you found this tutorial helpful, don't forget to give it a like. It really helps the channel grow and let me know you enjoy this kind of content. And if you want more Blender tutorials and 3D projects, make sure to subscribe and hit the bell icon. Thanks for watching, and I'll see you on the next one.